Good evening and a warm welcome to you, matriculants. Thank you so much for joining us this evening. We will start with today's session. Remember that today we are looking at paper one. We're going to look at three topics. It's going to be number patterns, functions, and calculus. With these three topics, you can definitely get a lot of marks on your exam. I know some people are writing tomorrow. That is why we started with paper two instead of paper one. This is meant to prepare you guys for tomorrow's exam if you are writing tomorrow. If you're not writing tomorrow, you still have quite some time to look at some more past papers to practice, so you are not under pressure. And I'm advising you to start practicing as much as you possibly can so that you are ready for your exam. Okay, so please make sure that you share the link with your classmates and friends who are in metric or family members who are in metric if they are doing pure mathematics, so that we can start with today's session. Just tell them that the session has started. I will be a little bit fast because, like I said, we are dealing with three big topics and there's so much that we need to cover in the 2 hours that we are given. Okay. My name is Tepang. If you did not manage to join the other session that we've had, please do watch or do check out our YouTube channel, because the videos have been posted or will be posted very soon, so that you can check what we did for paper two, because you will be writing paper two on Monday if you're writing paper one tomorrow. Okay. Now that I've introduced myself, I'm going to stop the video so that it can conserve our data and just to avoid having network challenges. Okay, I'm going to then share my screen so that you guys can see as I am doing the calculations. Please make sure that you do have pen and paper. Make sure that you have your calculator as well, because we will be doing a lot of work together. So I will give you guys some questions to attempt by yourself. And I urge you guys to try and calculate the problems that I give you so that you can see if you do understand or not, right? You are more than welcome to ask questions in the chat or in the Q&A. And we will try our level best to make sure that we address all the questions that are being asked. Very important. Please don't just say repeat. You need to be very specific. You want me to repeat question 3.1.1, or you want me to repeat which specific part of the problem? If you just say repeat, I'm definitely going to ignore that message because I don't know what repeat means in this context. You must be very much specific. All right. And please make sure that you try to pay extra attention, because I won't have time to repeat every single thing that I do. All right. Let me share my screen so that we can get started. All right, perfect. Let's get started. So like I said, we're going to be doing three topics: a number pattern, sequences series, functions, and some calculus. Because they are quite long, I'm going to try to be very quick. So without waste of time, into it. So the very first thing that I want us to look at would be the arithmetic sequences. All right. Now, arithmetic sequences are characterized by a constant difference between the terms. For example, we have -2, 1, 4, and 3. We can see that from -2, we added 3 to get to 1. From 1, we added 3 to get to 4. And then from 4 to 7, we added 3 again. So the constant difference there is 3. Right. Now, the general formula for an arithmetic sequence is given by Tn is equal to a plus open bracket n minus 1 with the difference outside multiplying the n minus 1, which is inside a bracket. Right. Now, Tn stands for the value of the term at position number n. For example, we're looking for term 5. Let's say we found term 5 in a specific or in a particular sequence, and term 5 gave us 30, for example. So term 5 gives us 30. Tn is the value of term number 5. A is the first term, n is the term position. And usually we call it the independent variable, and the difference, and D is the constant difference or the common difference, if you may. And how we calculate the common difference is we say T2 is T2 minus T1 must be equal to T3 minus T2, right? This can also be this way. It can be T3 minus T2 is equal to T4 minus T3. Okay, hoping that part makes sense. Remember, some of this is knowledge from previous grades. Okay, now let's look at this one quickly. Like I said, you must have pen and paper because we are going to do a lot of writing. So here's a test for yourself. Given the sequence 6, 3.5, 1, negative 3.5, all the way until Tn. Find the general formula of the sequence Tn. Okay, what's the first thing that we need to do? We need to check, is there a common difference? Is there a common ratio, a constant ratio? Okay, now let's check. I'm going to check what T2 minus T1 is going to give me. T2 minus T1. So this is 3.5 minus 6. What's the difference? The difference that I'm getting is negative 2.5. Right? If I do make mistakes, you are more than welcome to correct me. I'm going to try to pay extra attention so that I don't make any silly mistakes. But if you spot them, you're more than welcome to correct me. I am human as well. Okay. Now let's check if we say T3 minus T2, not T1, T2. That's the first mistake. Now this is going to be 1 minus 3.5, and that gives us negative 2.5. Here we can see that T2 minus T1 is equal to T3 minus T2. So we are dealing with an arithmetic sequence, right? And we do have a common difference or a constant difference, which is negative 2.5. So common difference, D, is that. Now, the first thing or the first instruction was to find what? The general formula. How do we find the general formula? Tn is equal to a plus open bracket n minus 1 multiplied by the difference. What is the very first term? 6 plus n minus 1. What's the difference? The difference is negative 2.5. Remember, it's negative multiplied by negative 2.5. So this is still 6 minus 2.5 n plus 2.5. Because the negative 2.5 multiplied by the negative 1 will give us positive. Now this will be 8.5 minus 2.5 n. And this will be our nth term or the general formula. Question number 2. Which term has a value of negative 45? So which term? We're looking for the value of n that gives us negative 45. That shouldn't be a problem because we're going to say Tn is equal to a plus open bracket n minus 1 multiplied by the difference. But we already have this. We've calculated it to be this. So in here, I'm just going to substitute negative 45 on the left-hand side because I'm trying to find the value of n. So not 45, 54. 54 is equal to 8.5 minus 2.5 n. Now, positive 2.5 n is equal to 8.5 plus 54. Hope everyone is with me there. Then from here, it's just simple math because we're just going to rely on our calculator for that. Okay, so this is going to give you 62.5 and 2.5 n on the left-hand side. So let's divide both sides by the 2.5. N gives us 25. Right? Hope everyone is with me there. Now remember that n has to be a natural number. Okay? You cannot have n is equal to 25.5. It cannot be a decimal. It can't be, because think about it. If I say to you, find term 1, you'll be able to find term 1. If I said to you, find term 3, you'll be able to find it. But if I said, find term 1.5, that doesn't even make any sense. Okay? So let's just erase that. Okay, there's a question in the chat. Let's quickly address some of the questions. Are we allowed to use Tn is equal to Bn plus C formula if we find it easier, and will we receive our marks? Yes, that formula will definitely work because this is a straight line. So, well, the formula is a straight line. We can relate it to a straight line, so that will work, and you will get marks for that. Okay, somebody got 25 as well. So I'm guessing I know that we are on the right track. Okay, now determine by calculation whether negative 25 is a term in the sequence. Okay, so what we're going to do for number 3 is we're going to substitute negative 25 and check if we are getting in. Right, not 25, but any other in. But if it gives us a decimal, then we know that negative 25 is not a term in the sequence. So let's address that question. So negative 25 is equal to 8.5 minus 2.5 in. Then 2.5 in is equal to 8.5 plus 25. Then we can say that 2.5 in is equal to 33.5. Then divide both sides by 2.5. N is equal to 13,4. So we know that this is not a term in the sequence. I hope we're all together there. Okay, if you're taking down notes, quickly take a screenshot. So I'll give you guys a chance. I'll give you like a few seconds to maybe take a screenshot at the end. When I'm explaining, please try to pay attention to what I'm saying and not to take down notes because you will be left behind. Okay, now that we are covered there, let's quickly move on. Now, here's another test yourself. So given that an arithmetic sequence has a 6th term equal to 39 and a 10th term equal to 83, determine the first term and the common difference. I see a lot of students struggling with these kind of word problems, right? But I want to break it down to you guys. So make sure that you are following every step of the way. We start here. Tn is equal to a plus n minus 1 multiplied by the difference. That's the general one. Now, they're saying 6th term. Note that sixth term will be a plus 5d. But how did we get that? Let's substitute. This is n. N is 6. So T6, n is 6, is equal to a plus, what is n? It's 6 minus 1 multiplied by the difference. Then we know that it will be a plus, what is 6 minus 1? It's just 5 multiplied by the difference. Okay, sorry about that. There we go. Now, if we were looking for, let's say, term 87, I immediately know that term 87 will simply be a plus 86d. Let's prove it. We know that we're going to say T87 is equal to a plus what? A plus 87 minus 1 in a bracket with a common difference outside. Then this is a plus 86d. So it's always one less. That's where we get it from. Okay, now that we're all on the same page, let's complete the question. So T6 is a plus 5d. Okay, I can erase this. And now you all know where it comes from. The 10th term is equal to 83. So T10 is equal to a plus 9d. But they told us what the 10th term is equal to. Here, the 10th term is equal to 83. So I can say that 83 is equal to A plus 9D. What do we know about term 6? We can simply say 39 is equal to A plus 5D. Can you see that we have two equations now? This is equation 1, and this is equation 2. We can solve for A in the very first equation, and that will yield A is equal to 39 minus 5D. I'm going to then substitute this in the second equation. So 83 is equal to, what is the value of A? A is 39 minus 5D. Then we still have plus 9 times the difference. Now, this is 83 minus 39 is equal to 4 times the difference. Then all we need to do is to calculate that 83 minus 39, and that should give you 44 is equal to 4D, which simply means that the common difference is going to be 11. Now it's going to be quite easy for us to find what A is, because what we're going to do there, so we're going to substitute this common difference in here. So we can say 39 minus 55, because it's 5 times 11, and that should give you A to be negative 16. So A is equal to negative 16, and the common difference is 11. Now they're looking for the 9th term, T9. T9 is equal to A plus 8D. We know where this comes from. What is A? We found it to be negative 16. 8 times, what's the difference? 11. And your answer should simply be 72. I hope everyone is with me there. Okay, let me just zoom out so you can take down a screenshot or take down some notes. I'll give you 10 seconds for that. Remember, if you have questions, please feel free to use the Q&A section to ask your questions. And I need to repeat that if you want me to repeat something, please be very specific with what you need me to repeat. Okay, so somebody's asking, where does 8D come from? Because we are looking for the 9th term. Remember that the general term is Tn is equal to A plus n minus 1 multiplied by the difference. Now, because it's the 9th term, we're going to substitute 9 wherever we see n. So T9 is equal to A plus n is 9 minus 1 multiplied by the difference. So simplifying this, this is still A. What is 9 minus 1? It's just 8 multiplied by the difference. That's what I was explaining in the beginning. So even if they say to you, what is, or find the 907th term, for example, so the 907, we know that we can say A plus 906 multiplied by the difference. It's always one less. Why? Because we get it from Tn is equal to A plus n minus 1 multiplied by the difference. Because they say 907, we're going to say A plus 907 minus 1 in a bracket multiplied by the difference. So A, 907 minus 1 is going to give you 906. I hope it's clear for everyone now. Okay. Now, finally finding that value. Oh, we did find it. A mistake. We found it here. I was just answering your questions. it was 72. Hope it's clear for everyone. Okay, somebody's saying that they got their T9 to be 70. Please make sure that you've substituted the correct A. The difference, remember, is 11. Okay, I'm just going to verify that I am not the one who made a mistake. Negative 16 plus 8 times 11. That gives me positive 72. So do make sure that you haven't made a mistake there. You can use simultaneous equations and you can find the formula, then calculate the value of the ninth term. Yes, you are allowed to do that. Okay, I was just addressing the questions in the Q&A. Right. Perfect. Now let's move on. Now let's look at a geometric sequence. Okay, so this one is characterized by a constant ratio, which is R. Okay, so we are multiplying the numbers by something which is the same. Remember in the previous one, we were adding. Now what we're doing is we are multiplying. And if we're multiplying by the very same thing, we say there is a constant ratio. Okay, let's just move this up, make a little bit of space there. Perfect. Now, for example, we have the sequence 1, 2, 4, and 8. Can you see that we are multiplying by 2 every single time? We started with a 1, then we multiply by 2 to get to 2. We multiply this 2 by 2 to get to 4, and we multiply the 4 by 2 to get to 8. Okay, now how do we find this constant ratio that we're talking about? We find it by saying that T2 over T1 must be equal to T3 over T2, right? Or we can say T3 divided by T2 is equal to T4 divided by T3. That's what's going to give us that constant ratio. Now, A is still the first term. And the general formula in this case would simply be Tn is equal to A multiplied by R raised to the power of n minus 1. That's for geometric sequences. Okay. Now let's look at this test for your test yourself together. Determine the general formula for the nth term of each of the following geometric sequences. Okay, I'm going to do one, and then you guys are going to attempt number 2. Firstly, let's locate A, or let's just take out A. A is going to be positive a half. That's the first term. Now, what is our R? To find R, we're going to say T2 divided by T1. So 1 over 4 divided by 1 over 2. T2 divided by T1. So this is the same as 1 over 4 multiplied by 2 over 1. Then we are going to get 1 over 2. Now let's check by doing T3 divided by T2. So 1 over 8 divided by T2, which is 1 over 4. This is the same as 1 over 8 multiplied by 4 over 1, and it will also give us 1 over 2. Because T2 over T1 is equal to T3 over T2, we do have a constant ratio. Okay? And we found it to be positive a half. Now let's find that formula. What can we say? Tn is equal to A multiplied by R to the n minus 1. Substitute what you have. A is 1 over 2. I'm going to just wrap it in brackets. And then our R is also 1 over 2. But R is raised to n minus 1. And you cannot say this is not equal to 1 over 4 to the n minus 1. We have to find what this is first. So be very careful there. Okay, I'm hoping that made sense. Now, I'll give you guys 45 seconds to attempt number 2. Don't worry about the x's. It just means that your answer is going to be in terms of x if they do not cancel each other out. So I'm letting you guys attempt number 2. Please do attempt it so that you can see where you went wrong if you don't get to the correct answer. Now, remember, I'm seeing requests in the chat. You need to be very specific. You cannot just say, please repeat again. What is it that you didn't get? You need to be very specific. Like I said, for the sake of time, I won't be able to repeat everything, but we are recording this session and it will be posted on our YouTube page. The link was posted in the chat already, but it will be posted again so that you guys can go and have a look at some of these recordings. Okay, you're now doing question 2. You have 30 seconds left. Okay. There's already an answer in the chat. Thank you so much for attempting. I'm acknowledging the answer. I'm not saying whether it's right or wrong, but thank you so much for attempting it. We have an answer being Tn is equal to x to the 3x, sorry. Let me just fix that. X multiplied by 3x to the n. X multiplied by 3x to the n minus 1. Okay, if you have a different answer, please do share it in the chat so that we can see who got it. And don't be shy to share answers. That's how we learn math. You get it wrong, and then you see your corrections, you rectify your mistakes. Then you don't make those mistakes again. Okay, I'll give you guys 30 more seconds if you're still working it out. Looks like we're getting the same answer. X multiplied by 3x to the power of n minus 1. All right. Perfect. Let's quickly look at it. The first thing that I want to do is to locate my a. That's just going to be x. And then what is r? T2 divided by T1, and that's simply going to be 3x. T3 divided by T2, that gives me the same thing, which is 3x. So this is my r. Now, what are we going to say? We're going to say Tn is equal to a multiplied by r to the n minus 1. Let's substitute what we have. A, that's x, multiplied by what's r? 3x. I'm just going to wrap everything in brackets. N minus 1. And this is the answer that was given. If you didn't get it right, I hope you can see your mistakes. And thank you so much for everyone that has attempted it. Remember what I say, guys. Please do attempt the questions that I give you so that you can see if you are following. If you're not following, do use the Q&A to ask some of those questions. And you need to be very specific. Now, here's another kind of a problem here. Given a geometric sequence with second term 1 over 2 and ninth term 64, determine the value of r. I need your guys' undivided attention. Tn is equal to ar to the n minus 1. Let's say we wanted to find term 1, 1, 1. So T111 is simply going to be ar to the 110. Why is it that? It's because we're simply saying ar n is 111 minus that 1. I hope it makes sense to everyone. Then what is the ninth term? How can we write the ninth term? It simply means the T9 is ar to the 8. What is the second term? Second term is simply going to be ar to the 1 or simply ar. Okay? Now let's finally answer this question. Determine the value of r. So I'm simply going to say ar to the 1 or simply ar is equal to what? is equal to 1 over 2. I'm also going to say AR to the 8 is equal to 64. Now, this is equation number 1. This is equation number 2. I'm then going to say equation number 2 divided by equation number 1. So AR 8 is equal to 64 over AR is equal to 1 over 2. So we're dividing. What cancels? The A's cancel. And then we're going to have R to the 7 is equal to 128. Now, what we need to do is to simply find the 7th root of 128. And R is simply going to give you a positive 2. Once we have R, we can find the value of A. Remember, we said what? AR is equal to 1 over 2. So A is equal to 1 over 2 divided by R. But we know that R is simply 2. So this is 1 over 4. This is 2, and this is 1 over 4. Then it's going to be quite easy for you to find the general term, because Tn is equal to AR to the n minus 1. What is our A? 1 over 4, in brackets, 2n minus 1. Okay, let's address some of the questions that are in the chat. Okay, so we Faith is saying, how is 64 term 8? Isn't that what they said? It's not term 8, it's the 9th term. Here, the 9th term is 64. The geometric sequence with the second term a half and the 9th term 64. You guys are not getting this. Remember that Tn is equal to AR to the n minus 1, and you substitute in the. Okay, see, Wipilo has got it. Okay, so it says, sir, may I please ask, when do we say plus or minus? Okay, so whenever you are finding the square root of an even number, if this was even, then we'd have to say plus or minus. When it's even, it's plus or minus. Okay. Okay, so some of the other questions are saying, why are we dividing term 8 with term 2? It's because we want to try and find R, right? So you don't have to divide. What you can do is you can equate the two equations to each other. You are still going to get the same thing. I personally like dividing the two equations, but if you are a fan of equating them together, we are ultimately going to get the same answer. And you can try it to see if it works. Okay, I'll zoom out for a little bit so that you can take a screenshot. I'll give you 10 seconds for that. Okay, what if I didn't divide, but I wanted to make A the subject of the formula, then equate them? That was also going to work. Okay, for the sake of time, I'm not going to equate them. I have to move on to other topics. So you can do it and then check if it works out. Remember, equating is just a matter of algebra. Your algebra skills must be on point. Okay, perfect. Moving on, let's go back. Okay, now here's a test for test yourself. I'm going to give you guys this one to try. I will give you guys a minute and 30 seconds to attempt these questions. So consider the pattern 5, -2, -7, and -10. Write down the next two terms, determine an expression for the nth term. Show that the sequence will never have a term with a value less than -11. Those are 3 questions that I want you guys to attempt. Check what kind of sequence we are dealing with first. Is it arithmetic? Is it geometric? Is it quadratic? They don't ask you about exponential sequences anymore or cubic ones. Once you have answers for me, please do type them in the chat. So the next two terms, this should be easy for everyone. Okay, I don't think it can be that difficult for you guys. Please do attempt it. Write down the next two terms. You can send an answer already. You can type an answer in the chat already. For question A. Okay, thank you, Fenze Mokwena. Thank you. We have -13 and -16. I'm just acknowledging the answers. If you found different answers, please do share them. We're going to check which ones are correct in a second. Okay, let's quickly check the first one. What's happening from 5 to -2? What happened? Okay, let me write it here. So 5, -2, -7, and -10. So here we subtracted a 7. Here we subtracted 5. And here we subtracted 3. So it means that we are adding 2 to this sequence here. So this will be -1. And this term will be +1. I don't know if you guys are with me there. So we're going to say -10 minus 1, which must give you -11. Or am I the one who's making a mistake? If I'm making a mistake, you're more than welcome to stop me, because everyone is getting -13 and -16. I'm going to just check again. Let me just complete this. So this is +2. This is +2. And this is +2. And this is +2 as well. Okay, now it means that I'm correct with the -11 there. I think people might have made a mistake there. And the next one is going to be -10, because it's -11 plus this one. So the correct answers are -11 and -10. If you got -13 and -16, I hope you can see your mistake. Be very careful of the signs. Negatives. Those are there to trick you usually. You need to be very careful in your exam. Now the next two terms, okay, let me just locate them here. Let me just write them here. -11 and -10, so I can just clean it up. Okay, now write an expression for the nth term, Tn. That's the next question. I'll give you guys 45 seconds for that one. Once you have an answer, please do share it. Okay, Gabrit already has it. Thank you for your answer, Gabrit. So let me just note it down. while the others are still working on it. Tn is equal to n squared minus 10n plus 14. Okay, if you have a different answer, please do share it. Okay, in the Q&A, I'm also getting n squared minus 10n plus 14. Right, looks like we are getting the same answer. Let's see, how do we go about getting the nth term? Right, you cannot afford not to get this right. Okay, so let's start here. 2a is equal to this. 3a plus b is equal to this. a plus b plus c is equal to this. We start from the bottom to the top. Start from the bottom, now we're here at the top. So a will be 1. 3a plus b is equal to negative 7. Don't forget the negatives. Then b is equal to negative 10 because the negative 3 went, the 3 went over to the side, it became negative. Minus 7 minus 3 is negative 10. Now, a plus b plus c must give you positive 5. Then we have a as 1, b as negative 10, and c. Just write this properly. Then we know we can solve for c, and this is going to give us 14 because this is 9. It's going to be negative 9. And then we take it over to the side, it becomes 14. And this is the correct expression. Hope everyone is with me there. Okay, thank you so much for attempting the question. It means that we are on the same page and you're not going to get this wrong in your exam. Now, show that the sequence will never have a term with a value less than negative 1. So they like these kind of questions, right? And they are very easy because this is quadratic. The moment you're dealing with quadratic sequences, I need you to start thinking about parabolas. Remember that parabolas can be sad-faced or they can be happy-faced. If it's a sad-faced parabola, it's going to have a maximum number. If it's a happy-faced parabola, it's going to have a minimum, right? And how do we deal with these? These are turning points. Okay, somebody's correcting me. Negative 11. So you said negative 1. I don't see where I said negative 1. I can't see that mistake. From Katlego, I'm not seeing that mistake, but please do check again. If you can still spot my mistake, try to be more specific. Okay. Now, as I was saying there, that we're thinking of parabolas. It's either we have a maximum or a minimum. And these are turning points. Now let's check, what is our A value? Right, remember that we have positive 1. So we are dealing with a happy face graph. Okay, maybe I misspoke and said negative 1 instead of negative 11. I apologize for that. Is it this? Okay, show that the sequence will never have a term with a value less than negative 11. Maybe I said negative 1 and I apologize for that. So let's find the minimum. Firstly, x is equal to negative b over 2a. We're dealing with the turning point. This is how you need to go about these kind of questions. Then this is going to be negative. Now our b is going to be negative 10. Remember that we're taking it from here, from this. Do not substitute this b. Okay? So make sure that this is, you've solved for it. Yes, I know it's negative 10. Make sure that it is proper because we took this and we substituted it there. So this is ax squared plus bx plus c. That's where I want you to get it from. Now, over 2, what is the a value again? The a value is positive 1. So this gives you how much? This gives you 5. Now that you've gotten this 5, what are you going to do with it? You're going to substitute it back in the original. So 5 squared minus 10 into 5 plus 14. Okay, and that should give you negative 11. So this is the minimum. This is the minimum value that the sequence can have. I hope it's clear for everyone. Yes, you can complete the square. You absolutely can to find those turning points, but make sure that you know how to complete the square. If you're not too comfortable with completing the square, do not even try to complete the square. Use the turning point formula. But if you're confident, absolutely. Okay, let me zoom out a little bit in case you want to take a screenshot. Okay, moving on. Now, let's talk about series. Okay, let's put that there. So what is a series, right? When you add a few terms in a sequence together, that is a series. So once there's a plus, you're dealing with a series. Okay? So for example, here we're saying Sn, the sum of a few terms that are in. So the sum to n terms. N can be maybe 10 terms. So if we're looking for sum to 10 terms, we'd add the first 10 terms together. And now we're dealing with a series. Okay. Now, we also have an arithmetic series. We also have a quadratic one. Okay. Now, the general formula for an arithmetic sequence is given by Sn is equal to n over 2 into 2a plus into n minus 1 multiplied by d, close the bracket. This is given on the formula sheet. Okay. But the last time I checked, they do require you guys to know where it comes from or to prove it. And I will show you guys how to go about it. So firstly, let's say Sn, we just discussed that it is the sum. Okay, so there is a question. Please redo the C steps, sir. The C steps. Let me see. To find this, we just said a plus b plus c is equal to 5. A was 1, b was negative 10. So 1 minus 10, that's going to give you negative 9. So this is the same as negative 10 plus 1. Right? Then you have c is equal to 5 plus 9. And that's how we got 14. This was the question in the Q&A. Okay, coming back here. So we just discussed that Sn is when we add a few terms together. And when we do that, we can say this is A. That's the first term. What is the next term going to be? It's going to be A plus a difference because we're dealing with arithmetic. What's the next one going to be? It's going to be A plus what? Plus 2D. And then we are going to have the last term or term n. So last term equals to Tn. So I'm going to say Tn. That's the last term. Now, what I'm going to do is I'm going to say Sn is equal to, I'm going to start here. I'm going to go in this direction from the right to the left, Tn. Now check something. What is the term before Tn? It's Tn minus d. Because we're subtracting if we're going from the right to the left. What's the term before this one? It'll be Tn minus 2d. So I'm going to say Tn plus Tn minus d plus what? Plus Tn minus 2d plus what? A plus 2d plus a plus d. There are some terms in between, remember. We don't know how many. Plus a. Now, this is equation 1. This is equation 2. Then let's add. So equation 1 plus equation 2. Sn plus Sn will give you 2Sn. Now, if you add this, you're going to have a plus Ta. If you add this, can you see that there's a positive d and a negative d? Those cancel. What do we have? A plus Ta. If you add this cancels that. What are you left with? A plus Ta. Now, there are some terms in between. We're going to have A plus Tn, A plus Tn, A plus Tn. Now let's check. This is going to be 2Sn is equal to. How many A plus Tn's do we have? We have n of them because there are a lot of them here in between that we don't know. So we can just say we have n times A plus Tn. But then we can say Sn is equal to n over 2 into A plus. What is Tn? Look at your formula sheet. Formula sheet says Tn is what? A plus n minus 1 multiplied by the difference. Now you can see something. These two can be added to each other. 2a plus n minus 1 multiplied by the difference. And this is our Sn. Right. For the sake of time, I'm not going to repeat it. Please do check out our YouTube and our TikTok. I did go in depth with this particular proof and the geometric one as well. I promise you I've done it on our TikTok page. Okay, now we need to move on. So I'm not going to do the sum for the geometric one, the proof, because it is there on our YouTube and our TikTok. Okay, this is the one that I want to focus on. An infinite geometric series. So this is when we are dealing with the sum to infinity. And the formula says a over 1 minus r. Okay, now we get an infinite geometric series if our r lies between -1 and 1. So if you find a value of r being between -1 and 1, it means that the series you are dealing with is infinite. You can find the sum to infinity. This series definitely does converge. So it gets smaller and smaller and smaller and smaller. It keeps getting smaller and smaller. Hence, we say the series converges. Okay, now let's look at the kind of question they're asking us. Calculate the values of x for which the series converges. This is how you're going to answer this question. You're going to say, to converge, -1 and +1 is where r must be found. It must be found between those. Now, what is r? R is equal to 2x plus 1, t2 divided by t1, which is equal to t3 divided by t2. You can check. I showed you guys how to go about it. Now let's substitute. Our value for r, -1, we found it to be what? 2x plus 1, +1. Then let's substitute. Let's minus 1 throughout. We're going to have minus 2 less than 2x less than 0. Now we divide throughout by 2. So we're going to have negative 1, x, and 0. And these are the values of x for which this series converges. That's how you need to deal with those kind of questions. Even if they have variables like x and y, the procedure is still the same. Okay. Now, quickly addressing sigma notation. What is sigma notation? Sigma notation is a shorthand instruction for us to add up a specific series of terms in a sequence. Okay, now sigma, we'll see it with the sigma symbol. This symbol means add, right? We must add a few terms together, right? And I always say to my students that this is what? Your Tn. This is your end point and this is your starting point. This does not mean the number of terms. That's where you need to end. Okay, let's address some of the questions. The recording will be posted the latest by tomorrow. It should be up on our YouTube. Thank you so much, the principal for Hotalang Secondary School. Thank you so much. Please do share the link with your learners so that they can join us. Right. Perfect. Now, moving on. Let's say they wanted you to find sigma or to write a series in sigma. The first thing that you need to do is find Tn. Once you've found Tn, that's what you're going to substitute there. And this is where you need to end, not the number of terms. If we check the series, we'll see that the number of terms are actually 7 because it's 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7. We're starting with the 4. So we'll substitute 4 here, then go to 5, 6, 7, 8, 9, and 10. Hope it makes sense. And you can do that for both your arithmetic and your geometric. Okay, now let's quickly look at this question here. This is from a past paper. Consider the geometric series 4 plus 2 plus 1 plus a half going all the way. Does this series converge? Justify your answer. Okay, for us to know that it converges, we need to find the value of r. Remember, it only converges if r lies between -1 and 1. So let's find r. R is equal to T2 divided by T1, which must be equal to T3 divided by T2. So if we do that, we're going to have 2 over 4, which gives you a half. If you did T3 divided by T2, you are also going to get a half. So this works. Right? Now, isn't it that r being 1 over 2 lies between -1 and 1? So you're going to firstly say r equals to 1 over 2. Then you're going to furthermore say that r is found between -1 and +1. A half is somewhere in between these two numbers. So the series does converge. The answer is a yes, because r lies between -1 and 1. Now they're saying, calculate the sum to infinity. So as infinity is equal to a over 1 minus r. What is a? It's 4. 1 minus a half. So this is just 4 over a half, which is simply 8. That's the sum to infinity. Okay, somebody's saying they didn't take a screenshot of the previous one. I don't know if it's this one. Okay, I'll give you 10 seconds for this. Please do take a screenshot. Okay. Perfect. Now we're going to move on. We're not going to do 2.2 because there's still more topics that we need to look at. Even 3.1, we won't have time to look at 3.1. I want to quickly address functions, which is a big one. I'm going to try to be a little bit quick so that I can do a little bit of calculus as well. So looking at functions, we have a one-to-one relation, or we have a many-to-one relation. Okay. Now, which one is a function and which one is not a function? So if it's not a function, so these things are relationships, right? And some relationships are functions, but some of them are not functions. Okay. And so this is a straight line. So it's a one-to-one relation, which is a relationship. And then we also have a one-to-many relationship, right? So so 2x answers will give us the same y value. Because we can just touch there, we're going to get the same y value. Many to one. 1x answer gives us 1y answer. Right? Now, which type of relation is not a function? So, if you are getting 1x value giving you 2y answers, can you see that 5 gives you this positive x answer, and 5 also gives you this negative y answer? This is not a function. Hope everyone is with me there. So we use the vertical line test, right? Which is exactly what I did there. So just draw a vertical line and you check how many times you're touching the graph. 1, 2. So it's not a function because you are touching it 2 times. Okay, let's quickly moving on. So which of these are not functions? I'm just going to take 2 at random. So this one here is definitely not a function, vertical line test. Touch it there and there, not a function. This, not a function because I'm touching it twice, which is at the top and at the bottom here. Right? Now, this one here, we're also touching it twice, which is not a function. But this is a function. This would be a function. This is what we usually refer to as a piecewise function, which you will deal with next year if you're going to take any math courses. Okay, so you just use the vertical line test to test for functions. Okay, now analysis of functions. So analyzing functions. Okay, now if you are looking for the distance between two functions, what you have to do is you have to say the top graph minus the bottom graph, right? And the reason we do that is because when we're saying top graph, we're actually saying y of the top function minus y of the bottom function. Remember, f of x means y, g of x means another y. And that is how you find the vertical distance. If you're looking for the horizontal distance between them, you just find x2 minus x1. That'll give you the horizontal. That's quite easy. Now let's look at this exercise together. Find the maximum length of AB such that AB is a vertical line, AB is a vertical line and A is on f of x, B is on g of x, and A is directly above B. Okay, I know it does look a little bit to the left, but we're going to say it's directly above B. So the maximum length of AB. That's going to be quite easy. Top graph minus bottom graph. So minus x squared plus 6x plus 12 minus open bracket 2x plus 1, because the negative needs to affect everything on the right-hand side, right? Or after that negative side. So negative x squared plus 6x plus 12 minus 2x minus 1. Negative x squared plus 4x plus 11. If I'm making a mistake, you're more than welcome to stop me, okay? This is equal to what? AB. Now, because we're looking for maximum, and we're in metric, we have done calculus, we are allowed to differentiate because we're looking for maximum, right? If you did not know how to differentiate, what you can do is you can find the turning point. So you're going to find AB prime. I like using calculus because I know it's straightforward. It's quite easy. So you're going to differentiate that. And then what you're going to do is find the x value, substitute it back in the original AB. You're going to substitute it back here. And then the y value that you get there is the maximum length of AB. Okay. We have 48 minutes left. I'm going to rush because I still need to look at some calculus. Analysis of functions. So this is where we are dealing with interval type questions, right? So they're saying to determine whether the product or quotient of two functions is positive or negative, basic rules of multiplication are considered. So if they say to you, f of x multiplied by g of x is greater than 0, or if they say f of x multiplied by g of x is less than or equal to 0, what you need to be doing is you cannot, please do not multiply the equations together. What you need to do is you need to analyze the functions. So for greater than 0, what are they saying? The product is positive because we want it to be positive. Greater than 0 means positive. Thus, both should either be positive or both should be negative. So it means that this has to be positive and this also has to be positive, because if you say positive times positive, you are going to get a positive answer. But if they're saying to you less than 0, they must have opposite signs. This or that. Do not attempt to multiply the equations to each other. You are going to get lost somewhere. Right. Now, what do we mean when a graph is positive? Above x axis. Negative below or under x axis. I hope we're together there. Now, let's look at this. For which values of x is f of x multiplied by g of x less than or equal to 0? Now we need to check. Because we want less than 0, it means that they need to have what? What did we say? Opposite signs. One must be positive and one must be negative. Now let's check. What did we say about positive and negative? We said that positive means above the x-axis. So let's start from the left. From the left, and I'm going to go to the right. It's under the x-axis, negative, 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 negative. That's not going to work. This region does not work because they're both negative. The next region, positive, because it's above, positive, 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 ending here. The other one is also positive, positive, positive. This one is going to be positive until infinity because it never turns back the straight line. That's always increasing. Now check something. From this point, this graph is now negative, negative, negative. This region does not work, but this region here going to the right works. And how do we represent that? We're going to say what? X is greater or equal. Let me just erase to see this point. It's 6. X is greater or equal to 6. At 6, it is 0. That's fine because they put the equal sign there. And then greater than 6, going to the right. This is still negative, whereas the other one is positive. Do not multiply, analyze. Okay. Now, inverse functions. Okay, so an inverse function does the reverse of its original function. We can compute the inverse function by interchanging the output y and the input x variables. Okay, now given a function f of x, we determine its inverse f dash 1 x with these generic steps. So you swap x and y in the original equation, you solve for y, and you express the new equation in function notation. Okay, so remember, when we invert, or when we find the inverse, we are actually reflecting along the line y is equal to x. Hope everyone is with me there. Okay, now let's check this one here. So we have y is equal to x squared, which is a parabola. If we invert it, if we reflect it along the line y is equal to x, we are going to have y, or the inverse, as plus or minus the square root of x. And how did we get that? Remember, we said, let's invert. So x is equal to y squared. Now, what you want to do is you want to solve for y. So solving for y, you're going to root both sides, but this is going to be plus or minus because it's an even number there. Then we're going to say y is equal to plus or minus the square root of x. Do not forget, if it's an even number, what can we say? We have to say plus or minus. Okay, somebody's saying they can't see this blue color, so this was something else. So here we were talking about Desmos. So it's not necessarily an app. It is available online for you guys. It's a graphing software or graphing calculator. Okay, it's not getting any better. So desmos.com. We just don't have time to quickly look at Desmos, but it is a graphing calculator that is online that helps you sketch functions. I will show you guys how to do it on our TikTok. Okay, more inverse functions. So the exponential function, right? So if you invert an exponential function, what you're going to get is a logarithm. Okay, now we had y is equal to b to the power of x. If we switch x and y, x is equal to b to the power of y. Now, how do you solve for y? If y is a power like that, you need to log both sides. I'll do it step by step. Now, the rule says if you have a power like that, you're going to say log of b. Then this is the log of x. Now you need to divide both sides by log of b. These two cancel each other out. Now you're left with y is equal to log. The rule says if you are dividing a log by another log, the bottom one is going to be the base and the x. But if you have a shortcut method that you're using, that's perfectly fine. I just wanted to show you where it comes from. Okay, now let's quickly look at this one here. So the question says the graphs of, excuse me, f of x is equal to x squared minus 2x minus 3 and g of x equals to mx plus c are drawn below. D and E are the x-intercepts and P is the y-intercept of f. The turning point f is T, which has coordinates 1 and -1. The graphs of f and g intersect at P and E. Write down the range of f. So the range of f, I'll show you how I write the word range. Okay, I know it's the incorrect way to go about it, but at least I remember the difference between domain and range because I always used to confuse the two. Now, range, I write it this way. Range. I know I'm dealing with the y values. Now they're saying the range, the y values, where this graph f exists. Are we all together there? Now, this is simply going to be y is greater or equal to what? Do we know? Oh, they gave us the turning point, t. I was about to ask, do we know the coordinates of t? We do. Y must be greater or equal to -4. Alternatively, you're going to say y is an element from, this is a hard bracket, not a soft one, -4 all the way to infinity. You never, ever write infinity with a hard bracket. You do it with a soft bracket because we have never found and we will not find the value of infinity. Okay, calculate the coordinates of D and E. That should be quite easy for you guys because you have the equation of the graph. I'm going to give you guys 30 seconds. Well, I'll give you 45 seconds to try and calculate the coordinates of D. Right, you're going to try and factorize there. If you're not too good with factorizing, please use the quadratic formula. You will not get penalized for the quadratic formula. So please do it quickly. You have 30 seconds left. Once you have an answer for me, please do share it in the chat. Okay, we got x is equal to -1. There should be another one. Or x is equal to 3. Okay, thank you so much, Ralewa. If you have different answers, please do share them. Okay, quickly looking at this, we know 0 is equal to x squared minus 2x minus 3. And then if you try to factorize, 0 is equal to x. Then I have negative, I'm going to have a plus and a minus. Then I need a -2, so I'm going to say this is a 3 and that's a 1. Hence, the coordinates of D are going to be -1 and 0. And then the coordinates of E are going to be 3 and 0. As easy as that. Okay, I was asked to repeat the log change thing. So I'm quickly going to recap the steps. So this was given. All we did is we substituted or we swapped x and y. Once you've swapped x and y, you log both sides. You introduce a log in front and another log in front there. Now, because you've introduced a log in front, the rule says this can come down. It's like you're doing a derivative, but you don't subtract -1. So you're bringing the y in front there. So y log b is the same as log b to the y. But then because you want to solve for y, you divide both sides by log b. That's why these canceled out. So when you have log of x divided by log of b, it's the same as log base b and x. Okay. Then determine the equation of g. So g is the straight line. That shouldn't be a problem at all. Why? We have the coordinates of e, which are 3 and 0. This we can find. That's the y-intercept of the parabola and the straight line, but the straight line is not going to help us. So we know that this is going to be 0 and -3. Now you can find the equation of that straight line. Okay, let me just bring this up a little bit so we can check there. So the gradient is simply going to be +1. So m of PE is equal to 1. Now you can use any point. Y minus y1 is equal to m into x minus x1, or y is equal to mx plus c. It doesn't matter. Y plus 3 is equal to 1 into x minus 0. Y is equal to x minus 3. If you use y is equal to mx plus c, you're going to get the same answer. Thank you, Katlego, for your answer. You got the same answer as me. Now, quickly moving on, write down the values of x for which f of x minus g of x is greater than 0. Okay, a lot of people struggle with this kind of a question. So let's see what we can do. And remember what I said, we are analyzing. You do not want to subtract, you do not want to multiply the equations by each other. What you're going to do is you're going to take this to the right-hand side. So f of x is greater than g of x. So what does this mean? This is something that we've discussed. F of x must be on top of g of x. So remember the crocodile mouth eats the bigger number. So f of x is on top of g of x. Where is f of x on top? If we're here and we look up, we're going to see f of x on top. So this region. From here, it's on top. Is there anywhere else where it's on top? Absolutely here. That's where it's on top. Now, what are those two regions? The values of x. So x firstly must be what? Less than 0, or x must be greater than 3. And those are the values of x for which f of x minus g of x is greater than 0. If you try to subtract them, you're going to have problems. And remember what they said, write down. So there isn't a calculation involved. Hope that's clear for everyone. Okay. Moving on. Let's look at some calculus in the last 30 minutes. Okay. So the very first question says, determine f prime of x from first principles if f of x is equal to 1 over x. Now, what I always say is I always find the answer using the power rule first. So before we differentiate, what our function, or what we're differentiating, must be in the form k, x, and n, so that the derivative becomes n times k times x to the n minus 1. I know that can be confusing, but look at something like this, 2x to the power of 7. If you were to differentiate that, you know you have 7 times 2 times x to the 7 minus 1, which simply gives you 14x to the 6. So it must be in this form, a constant k multiplied by x to the power of n. Okay, now let's look at this one here. How can we write this? This can be x to the power of -1. Okay, if I do have time, I will come back to the other question, but I do have to look at calculus. There isn't enough time, but if we finish calculus, I'll definitely come back here. Okay, Bupila, you haven't really missed out on anything hectic, because I was just saying for you to differentiate, it needs to be in this form, a constant, right? A coefficient of x, the x, and the power, and the derivative is just going to be following this, where you multiply the front by n, multiply by the coefficient, multiply by x to the n minus 1. Now this is 1 over x. We know we want to get it in the format k, x, and n, which is exactly in this form, because this is k, we have x, and we have our n, which is a negative. Now, if we differentiated this, we're going to have -1 multiplied by x to the -1 minus 1, which is just -1 x to the -2. Using the power rule, this is the answer that we need to get, or just -x to the -2, or simply -1 over x to the 2. Okay, now let's then use first principles to find this. Yes, Inatu, I was just showing you guys that this is the answer that you need to get If we don't get this, then we're wrong. We've made a mistake somewhere. Okay, let's just erase this so we can quickly use those first principles. Now, the formula is given on the formula sheet. You do not have to memorize it. If we had time, I was going to show you guys where it comes from, but unfortunately, we do not have time. So f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, you cannot just decide to drop the limit. Once you decide to drop the limit, that's when you're deciding to lose 1 mark because they will penalize you. Okay? Now, I'm going to write the limit as h tends to 0 every single time. Now, I have 1 over, it has to be x plus h, minus what? Minus 1 over x, all over h. Then, this is the limit as h approaches 0. We still have h down here. Now, how do we subtract fractions? We need to find an LCD. And how we find an LCD? We just multiply the two denominators. Okay, then we're going to have x minus x plus h. This is just basic algebra. Make sure that your algebra skills are on point. The limit as h approaches 0. We still have a denominator of h. And then up here, we have a denominator x plus h. Then x minus x is going to fall away, and we're left with negative h. Now, this is the limit as h approaches 0. We're dealing with negative h over x into x plus h divided by h. So instead of writing this division line, I use the division sign. The limit as h approaches 0, negative x and negative h over x into x plus h multiplied by 1 over h. Now, this cancels that. The limit as h approaches 0, because I don't want to lose any marks, negative 1 over x into x plus h. Now, finally, f prime of x is equal to negative 1 over x squared. And this is the answer. Hope it's clear for everyone there. And remember, you do not, please do not make this 0, right? You can just ignore it. H approaches 0, but H is not 0. So there's a question. Okay, what if I don't do it this way, but still get the same answer? Yes, but it must be first principles. Firstly, you must start here. You have a different way of doing it, but as long as it's first principles, that's perfectly fine. You will get the marks. So how is it negative 1? It's negative 1 because, so x minus x. So what I did for this step here, I said x minus h. These two cancel each other out. Then we have negative h. Now negative h and this h. So these h's will cancel each other out here. But what's left? The negative is still left, hence the negative 1. Okay, why is h not 0? H is not 0 as per the instruction. It approaches, it's a limit. So h approaches 0. The reason h is not 0 is, if h was 0, then this whole thing becomes undefined because now you're dividing by 0. So h approaches 0. Okay. Now, this kind of a derivative here, d over dx. Remember that we have different notations. There's Euler, there is Newton, and there's Leibniz. I forgot the other one, but these are just different notations. Okay. So let's address some of the questions in the Q&A. So if you substitute 0, like I just explained, that it is going to be undefined. H is never 0. H approaches 0. That is why we just ignore it at the end. It is very, very small. It's very close to 0, but it is not 0. Once you substitute 0, it's something else, right? So I get why they said substitute 0, but please just ignore it. Don't substitute it to be 0, but what they were just showing you is that it will fall away. Okay, now quickly looking at this derivative here. This is going to be quite easy because firstly, we must remember kx to the n. Let's get everything in that format. So we have 4x, let's just quickly fix this. This is 4x to the 6. Instead of writing a square root, we're going to say to the power of a half. Okay, this is plus root 2x squared. Only the x is squared. Let's clean this up. It's not in this format, so let's clean this. It's going to be 2x to the 3 plus root 2x squared. Do not make the mistake of saying it's x because it's under a square root. It's not under the square root. Differentiate. So now d over dx of that is going to be equal to what? 6x squared plus 2 root 2x. Hope that's clear for everyone. Okay, moving on. 8.2.2. We need to find the g prime. Okay, now for you to find the g prime, what do we need to do? We need to get it in that format. G of x is simply 3x to the 4 over x squared minus 4x to the 2 over x squared plus 6 over x squared. G of x is still 3x squared minus 4 plus 6x to the minus 2 before we differentiate. Okay, this was a common factor. I broke it apart. Now we can differentiate. G prime of x is equal to 6x. This falls away, and let me show you why it falls away. The derivative of constant is 0 because we write it this way. Kxn. Now 0 times 4, you're going to have 0, multiply by negative 4, multiply by x to the 0 minus 1, then plus, let me see, minus 12x minus 3. Now, whenever we're multiplying by 0, this is going to fall away. 0 multiplied by anything gives you 0. Okay, then this is just 6x minus 12 over x to the power of 3. So somebody, is asking, why is it 6x squared? Because it's 3 multiplied by 2, which gave us 6. And then from the 3, you subtract 1, you get 6x squared, if this is what you were asking. Okay. You are supposed to carry on saying, so for this one, you have to keep writing this d over dx, d over dx. You only drop it here. at the very end. Thank you so much for that one. Okay, now let's look here. The equation of the tangent to f of x is equal to 3x squared plus bx plus c at x is equal to 1 is given by y is equal to 9x minus 9. Determine the values of of b and c. Determine the values of b and c. Okay. Now, the tangent to this graph at x is equal to 1 is given by this. Now, what we want are the values of b and c. Okay, somebody's asking to take a screenshot. This is not dy over dx. It's just simply d over dx. Okay, you can take a screenshot of that. And then I'll give you guys just a minute to attempt 8.3. Please make sure that you do attempt 8.3. We will do it together shortly. I've been doing a lot of talking and I'm losing quite a number of people. So I'm giving you guys one to try by yourselves. As soon as you have an answer, please share them in the chat. Or you can use the Q&A. Okay, you have 40 seconds left if you're working it out. Just make space in the meantime while you're working it out. Please don't be shy to share some of the answers that you guys got. Okay, I'm getting answers in the Q&A and the chat. Thank you so much for that. We got B is equal to 3, and we also got C to be -6. We're going to check just now. I'll give you 15 more seconds if you're still working it out. Try to be a little bit quick. Perfect. Let's look at it. Thank you so much for attempting it. So I'm going to start here. F of x is given as 3x squared plus bx plus c. Now, f prime of x is going to be 6x plus b. Okay. Now what I'm going to do is I'm going to substitute the one that they gave me. Right. At x is equal to 1. So f prime of 1 must be equal to what? Must be equal to 9. Why is it 9? Because that's the gradient. Remember, f prime means gradient. F prime is the general derivative, but where they touch each other, it's going to be the derivatives or the gradients are going to be equal. And where are they touching each other? At the x value of 1. Now I can say this. 6 into 1 plus b is equal to 9. Then b is equal to 3. Furthermore, we can use this as a point. So I'm going to say f of 1 is equal to 3 into 1 squared plus b into 1 plus c. But I know what the value of b is. Right. Now we're going to say 0 is equal to 3 plus 3 plus c. Okay, let's write this properly. Okay, now our c is going to give us -6 if we take the 6 over to the other side. So the values of b and c are 3 and -6. Okay, if you didn't get our answers, I hope you can see where you went wrong. Okay, quickly take a screenshot so we can move on. Okay, now let's look at this question here. Okay, let's see. Right, so there's 2 problems left. So the graph of f of x is equal to ax to the power of 3 plus bx squared plus cx minus 5 is drawn below. E has coordinates -1 and 0, and G has coordinates 5 and 0 are the x-intercepts of f. Show that A is equal to 1, B is equal to -3, and C is equal to -9. So this is like a proof. Okay, somebody's asking why 9. Okay, so this was the previous question. Remember what I said, that the gradients are equal wherever they touch each other. So let's say we had a graph like that looks like that, and this was the tangent. At this point, their gradients are equal. So we know the gradient of the straight line at this point, it's 9. It's the very same gradient of the graph. That's why it's 9. Okay, you can quickly take a screenshot. Give you 10 seconds for that. Okay. So show that A is equal to 1, B is equal to -3, and C is equal to -9. Okay. So what I'm going to do is I'll take the function. So f of x is equal to ax to the power of 3 plus bx squared plus cx minus 5. What I'm going to do is I'm going to substitute the point. Which point am I going to substitute? I will substitute let me use, let me see if I can. I'm going to say -5. Why -5? Because it is the y there, right? -5 is equal to a into, now, this is a turning point and it's also an intercept. So check what I'm going to do. I'm going to say 0 plus 1, but squared. 0 minus 5. Okay, where it comes from is from here. f of x is equal to a into x minus x1, x minus x2, x minus x3. This we know 0 and -5. So check. What we did is we substituted the 0 and -5. So we had -5 is equal to a 0 minus x1, 0 minus x2, 0 minus x3. Now we substituted point E, but we can substitute it twice. So -5 equals to a into 0. Then what will I say? I'll say minus 1, which is just +1. You can substitute twice because turning point and an intercept, right? So 0 plus 1. And then the other one is going to be 0 minus 5. We're all together there. Now, you solve for A. A must give you +1. Hope everyone is with me there. We're winning because we got the A value. Now, B must be -3. Okay, so what I'm going to do there is I'm going to say f of x is equal to a, which is 1, into x minus 1, which is going to be +1, x minus -1 again, and then x minus 5. Multiply that out. So this is going to be x squared plus 2x plus 1 multiplied by x minus 5. And then if we FOIL this out, we're going to have x to the power of 3 minus 3x squared minus 9x minus 5. Our A, our B, our C, if that's how it was laid out. Yes. So B is equal to -3. C is equal to -9. Yes. Gilbert, you're absolutely right. We can square it. I just wrote it twice so that everyone can follow. Because when I wrote it here, I knew that people will not be able to follow. Okay. Now use the graph to determine the values of x for which f prime prime of x, let's see, okay, for which f prime prime of x multiplied by f of x is greater than 0. What do we know about f prime prime? So f prime prime will be the point of inflection. Okay, let me just move this up. See if we can put it somewhere here where we can see the graph. Now, the function that we had was x to the power of 3, x to the power of 3 minus 3x squared minus 9x minus 5, minus 9x minus 5. So differentiating twice. So differentiate once, you're going to have 3x squared minus 6x minus 9. Differentiate again, you're going to have 6x minus 6. Now, if we try to solve for x here, we're going to have x minus 1 because this is equal to 0. Now we know that x, it will be a point of inflection where at x is equal to 1. Okay, now let's check. We're saying the product will give you greater than 0. Now, where will the product be greater than 0? Okay, so we already have this. Found x to be positive 1. It's going to be somewhere there, right? Now, my graph is going to be something that looks like that. The point of inflection graph, the second derivative, it's going to look something like this. Now check something, that from here, this is positive, positive. It's going to keep going up. The same thing here. This is positive. Because they're both positive, it works. But here, it doesn't work. It works from this point here. Negative, 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 negative. Okay, now, how we're going to answer them? We're going to say that x must be less than I'm seeing something. I said negative here, but check here. Negative, 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 negative. This is still negative. So it has to be from 1. Why is it 1? This is the point 1. 1 and 0. That's why we differentiated twice. So for x is less than 1, that works. Or for what? For x is greater than 5. Greater than 5 is this region here. So from here, going to the right-hand side. From this point here, going to the left, they're both negative. Hence, our answer is x is less than positive 1 or x is greater than positive 5. So somebody's asking, can I use synthetic division to solve 9.1? I don't think synthetic division is going to work for you here because you don't know what you're dividing by. But if it works, I stand corrected. I think it might be quite complicated as well to look at it using synthetic division. So I always take the easy way out, or I try to take the easy way out. Okay. So if you're taking a screenshot, here you go. You can take a screenshot quickly. Okay. You can take a screenshot there quickly as well. Okay. Then the last question, for which values of t will the graph of p is equal to f of x plus t have two distinct positive roots and one negative root? Okay, let's take this up. Okay, I'm gonna try and paste it up there. Okay, so let's relate. Yeah, it's related to this graph here. Zoom in. There we go. We want the graph to have two positive roots and one negative root. Okay, I want to explain something. Let's draw a horizontal line at the turning point. Okay, I'm going to draw two horizontal lines. So the first line, then I'm going to draw. So these lines are parallel to the x-axis, passing through the turning point. So this is one. How many times are we touching the graph at this line here? So we're touching it once, twice. Are we together there? Now, on the x-axis, how many times are we touching the graph? Once, twice. So that is giving us two roots. What is the question saying? Two distinct positive. So the roots must be on the right-hand side. Right? So from here, so anything here, from here going to the right, because we're going to have two roots. Now, let's check. We need to find what this value is. And this is going to be quite easy for us to find that. We're going to just differentiate. And then once we've differentiated, we're going to equate to 0. So 3x squared minus 6x minus 9 is equal to 0. And then all you do is you solve for x. So x squared minus 2x minus 3 is equal to 0. And then we know x and x, minus 3 and positive 1. So x equals to negative 1, or x is equal to positive 3. Now, because it's positive 3, we're going to substitute it to find the corresponding y value. And the corresponding y value there should give you 32. So 3 and 32. Now, we know that this is negative 5. Now, if we're anywhere in between the 32 and the negative 32, my mistake, the negative 32 and the negative 5, we're going to touch the graph. Let me just draw it a line here. Positive x, another positive x, 1 negative x. So anywhere in between, let me just use a different color, somewhere here as well. Positive, positive, and a negative. So anything between negative 5 and negative 32 works. Hope everyone is with me there. And this is how you deal with those kind of questions. Okay, that was the last question. The time is 2 minutes after 8 o'clock, and we are going to end here for today. I know that people are writing their exams, not everyone. Some people are writing tomorrow. I wish you all the best for tomorrow's exam. Otherwise, if you are only writing a little bit later, please do study very hard. Make sure that you do a lot of past papers, but look at the May, June exams only, because you haven't covered everything yet, and we don't want you to get confused. Okay. Otherwise, from us at the Learning Space, it's been a pleasure having you guys. Good luck for your exam.